Okay, so in class we ended with talking about using the noble gas configuration. What the noble gas configuration does is it allows us to shorten how much we have to write. Okay, so we basically end at the P6 that corresponds to the previous noble gas, which in this case is xenon, because of hafnium is, why do I always lose hafnium on this thing? 5D2, right here. Oops. Hafnium is right here. And so basically that makes xenon here my previous noble gas, okay? And then I start on the row number. This is 6s2. Because of the star, I have to go down here, and these first rows of the F's are 14, and then 5D, 1, and 2. Okay, so I don't have to write anything that is above the xenon. So the noble gases that I choose, this is the noble gas here, okay, and these are what the noble gas, this is noble gas configuration for the previous noble gases, okay. Now, so any noble gases when P is 6, okay, the elements are not reactive. That's how I got the name of being a noble, because at the time, nobles, royalty, did not interact with the common folk at all. You also have something called pseudo-noble gas, okay, and that's when my D subshell is full. And so on this graph, on this figure here, these are my D10s, right? And so those are also not counted in my valence electrons. Valence electrons are the electrons that are used in chemical reactions. Okay, so they're the ones that either are exchanged or are shared in a chemical bond, which is definitions we'll get to in the next chapter. Okay, and so basically it's any electron that's not in the noble gas or the pseudo-noble gas configuration. So this right here shows the electron configuration for selenium. Okay, so selenium is 1s2, 2s2, 2p6, 3s2, 3p6. Okay, and so then I have the 4s2, so that's here, the 3d10, which is this right here, and then the 4p, 1, 2, 3, 4. And so selenium has 6 valence electrons and 28 core electrons. So the question becomes to write the valence shell configuration of bismuth. Okay, so we have to find bismuth first, and bismuth, I found it that way, gotta find it this way. Bismuth is right here on the periodic table. So the previous noble gas is xenon. So I have xenon. Okay, I come down here. This is the 6th row. Okay, so it's going to be 6s2. Right. Again, this is down into the F's. The F's are n minus 2. So n is 6. So minus 2 gives me 4, 4, F, 14. Okay. I come across my D's, and so then I have, and the D's are n minus 1, so it's 5 D10, and then into the, back to the 6 S's, it's 1, 2, 3, or I'm sorry, P's, so 6P3. So the valence electrons of these, of this configuration is the 6s2 and the 6p3. So there are 5 valence electrons. for bismuth. We're not even going to count the F14s there. Okay. And that's the end of this video.